All right, guys, today we're going to be going through linear trends in data. I don't know why they put it that way. Really what we're doing today is finding the equation of a best fit line, okay? This is lesson 6.08, and here's the context. I don't know, some of you may have been to the Great Wolf Lodge water park, but what they wanted to do at the water park is they wanted to gauge, does the outside temperature have an influence on how many people come into the park? So what they did is they hired some kid on, summer vacation, and he sat there at the gate and he recorded what was the temperature and how many people came into the park. Pretty simple job. All right, so what happens is they got this data, okay? So here are the temperatures and here's the attendance. Now, these are the attendance in thousands. So if you see 36.8, that really means 36,800 people. And what we want to do is we're going to plot this, we're going to draw a best fit line, and then we're going to calculate the equation of that best fit line. Notice I've got two additional columns, and I'll be explaining that in just a minute. Okay, I've gotten ahead, and I've actually created the graph already. So if you need to, go ahead, pause the video, write down what you see, okay, and you can catch up. So again, let me come up here. There's a zoom in on the data table, so you can pause the video, write that down. And here's the graph. You can pause the video and write that down. Now, first thing I want to do is I want to draw a line through this data, okay? Well, there's something called the balance point. Think of it like, you're going to balance a ruler, okay? Well, you're finding the balance point of the line that you're going to put through this data. The balance point is the average of the input and the output. So the balance point is going to be the average of this column and the average of this column. So if I add all those up and divide by how many they are, here's what you get. If I add the temperatures up, X bar, now that might be new to a lot of you, but an X with a line over it means the average or the mean of something. The average of the mean of the temperatures is 80, and Y bar, or the average of the Y values, is 47.1. Okay? So I'm going to come over here, and I don't know if I'm going to have room, but the balance point equals 80, 47.1. Now, if you go to the notes, you'll see I've got a paragraph here. It says the balance point of a best fit line is the average of the data sets. I'm not going to take up your time in the video to write that, but if you go to the notes online, there's a little comment right here that explains where the balance point came from. Now, what I want to do is plot that down here. So 80 and then 47.1. So there's 40. 45, 47.5, so right about there. That's my balance point, and it is at 80, 47.1. Okay, now, when I go to draw my best fit line, I'm going to send it through that balance point. So, when you're doing a best fit line, you kind of want to balance the points above and below the line. So I'm going to take this and I'm just going to eyeball through here. It's like you're seeing now. It's just an eyeball at this point. There is a way to calculate it, and we're going to get to that. But right now we're just eyeballing that best fit line, and it goes through my balance point. Now we need to find the equation of that line. Well, first thing we need is we've got to find the slope. All right, well, don't pick one of the points from the data table. Pick points on the line because it's the line that we want the equation of. So I'm going to come down here and I'm going to choose this point. That looks like it's at about 62 degrees and 34,000 people. And then maybe I'll come up here and I'll choose a point way up here. And that looks like it's at about 100, so 100 degrees and 62,000 people. Now, I like to spread these points apart as far as I can. The further apart you pick those points on the line, the more accurate your slope's going to be. Don't pick two points that are right next to each other. because there's a lot of room for error. So slope, m, equals delta y over delta x. So I'm going to go 34 minus 62, there's the change in the y's, over 62 minus 100, there the change in the x's. So that gives me negative 28 over negative 38. And I'm just going to say, you know what, that's close enough to 2/3. Okay? It's going to be fine for what we're doing here. Now, I've got the slope, so I need the intercept. Now, I don't want to eyeball the intercept because what I want to do is take advantage of having calculated that balance point. So I'm going to use the point slope. Y minus y sub 1 equals m times x minus x sub 1. I'm going to use the point slope form, and I'm going to use my balance point as x1, y1. Okay, so I've got y minus 47.1 equals 2/3 times x minus 80. And there's the equation in point slope form. I'm going to take that and convert it to slope intercept form. So I'm going to distribute the 2/3 and add 47.1 to both sides. And I get y equals 2/3 x minus, and that would be, well, 2/3 times 80, add 47.1, we'll call it about 6.2. Okay? So there we go. Now, oh, this might look funny as a y-intercept when you go, well, wait a second, the line looks like it's crossing at about 32. Now remember, this keeps going until the x-axis says 0. This x-axis is only going to 60. So that would keep going down until it got to about this. So there you go. There is the equation for our line of best fit. Now I'm going to pause the video here and do a second video and explain what these two columns are. So I'm going to back off. There you go. If you need to pause the video, you can get all this written down. I'm going to come back in the